The minimum polarization index, or pi, value for vacuum pressure impregnated, also known as VPI, dry-type transformers in a 15 kV to 480W/277 volts range is 2.0. Polarization index values above 2.0 typically indicate a good insulation condition within the transformer. Conversely, polarization index values below 2.0 may suggest potential issues such as moisture ingress or other insulation degradation problems. Several factors can contribute to low polarization index values in VPI dry-type transformers. Firstly, moisture contamination is a common culprit. Moisture can significantly reduce the insulation resistance and affect the polarization index. Secondly, partial discharge activity within the transformer can also lower the polarization index value. Partial discharge degrades the insulation over time, leading to reduced polarization index readings. Thirdly, overheating can cause insulation breakdown and consequently lower the polarization index. Elevated temperatures accelerate the aging process of the insulation material. Fourthly, the natural aging of the insulation material itself contributes to a decline in the polarization index over the lifespan of the transformer. If polarization index values are consistently below 2.0, it is recommended to conduct further investigation to identify the underlying cause of the low readings. This investigation may involve performing additional tests to assess the condition of the transformer's insulation. One such test is the dielectric absorption test, which provides more detailed information about the insulation's ability to absorb electrical energy. Another useful test is dissolved gas analysis, or DGA, which involves analyzing the gases dissolved in the transformer's oil to detect any signs of internal faults or insulation degradation. When interpreting polarization index values, it's important to consider the specific transformer model, operating conditions, and historical data. Comparing current polarization index readings to previous measurements can help identify any trends or changes in the transformer's insulation condition. Additionally, it's essential to follow the manufacturer's recommendations for testing and maintenance procedures to ensure accurate and reliable results. Regular testing and maintenance can help prevent unexpected failures and extend the lifespan of the transformer. In summary, a polarization index value of 2.0 or higher indicates good insulation condition in VPI dry-type transformers, while values below 2.0 warrant further investigation to identify and address any potential issues. Monitoring polarization index values over time and performing additional tests as needed can help maintain the reliability and performance of these critical electrical assets. Vacuum pressure impregnation, or VPI, is a process used in the manufacturing of dry-type transformers. It involves immersing the transformer windings in a resin and then applying vacuum and pressure to ensure the resin penetrates all the insulation layers. This process enhances the electrical, mechanical, and thermal properties of the transformer, resulting in a more reliable and durable product. Dry-type transformers are often used in applications where safety and environmental considerations are important, such as in hospitals, schools, and commercial buildings. They do not use oil as a cooling medium, which eliminates the risk of oil leaks and fires. Instead, they rely on air circulation and convection to dissipate heat. This makes them a safer and more environmentally friendly alternative to oil-filled transformers. When selecting a dry-type transformer, it's important to consider the specific application requirements, including the voltage, kVA rating, and insulation class. The insulation class determines the maximum operating temperature of the transformer and its ability to withstand voltage stresses. Higher insulation classes provide greater protection against insulation failure. In addition to polarization index testing, other common tests performed on dry-type transformers include insulation resistance testing, turns ratio testing, and impedance testing. These tests help verify the transformer's electrical characteristics and identify any potential problems. Insulation resistance testing measures the resistance between the windings and ground, providing an indication of the insulation's condition. Turns ratio testing verifies the accuracy of the transformer's turns ratio, which is the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. Impedance testing measures the transformer's impedance, which is a measure of its opposition to the flow of alternating current. Regular inspection and maintenance of dry-type transformers can help prevent unexpected failures and extend their lifespan. This includes visually inspecting the transformer for any signs of damage such as cracks, corrosion, or loose connections. It also includes cleaning the transformer to remove dust and debris, which can impede airflow and cause overheating. In addition to the tests mentioned earlier, other advanced diagnostic techniques can be used to assess the condition of dry-type transformers. These include frequency response analysis, or FRA, and partial discharge testing. Frequency response analysis involves injecting a range of frequencies into the transformer and measuring the response. This technique can detect subtle changes in the transformer's winding geometry, which may indicate insulation degradation or mechanical damage. Partial discharge testing detects the presence of partial discharges within the transformer's insulation. Partial discharges are small electrical sparks that occur when the insulation is stressed by high voltage. They can eventually lead to insulation breakdown and transformer failure. When performing polarization index testing, it's important to use a calibrated megometer and follow the manufacturer's instructions. The test should be performed with the transformer de-energized and isolated from the power system. The megometer should be connected between the windings and ground, and the test voltage should be applied for a specified period of time. The polarization index is calculated by dividing the insulation resistance reading taken after 10 minutes by the reading taken after 1 minute. A high polarization index indicates better insulation condition. In addition to the factors mentioned earlier, other factors that can affect the polarization index include the temperature and humidity of the environment. High temperature and humidity can reduce the insulation resistance and lower the polarization index. Therefore, it's important to perform polarization index testing under controlled conditions whenever possible. When interpreting polarization index values, it's important to consider the transformer's operating history and maintenance records. A sudden drop in the polarization index may indicate a developing problem, while gradual decline may be due to normal aging. By monitoring polarization index values over time and performing regular inspections and maintenance, you can help ensure the reliable operation of your dry-type transformers. Furthermore, it's crucial to ensure that the transformer is properly ventilated to prevent overheating. Obstructions to airflow should be removed, and the transformer should be located in a well-ventilated area. Regular cleaning of the transformer's cooling fins can also help improve its cooling efficiency. Additionally, it's important to monitor the transformer's load and ensure that it is not overloaded. Overloading can cause the transformer to overheat and shorten its lifespan. If the transformer is consistently operating near its maximum capacity, it may be necessary to upgrade to a larger transformer. Another important aspect of transformer maintenance is proper grounding. The transformer's grounding system should be inspected regularly to ensure that it is intact and functioning properly. A faulty grounding system can create a safety hazard and damage the transformer. Surge protection devices should also be installed to protect the transformer from voltage surges caused by lightning or switching operations. These devices can help prevent insulation breakdown and transformer failure. When performing any maintenance or testing on dry-type transformers, it's essential to follow all safety precautions and wear appropriate personal protective equipment. This includes wearing safety glasses, gloves, and hearing protection. Only qualified personnel should perform maintenance or testing on transformers. Finally, it's important to keep accurate records of all inspections, tests, and maintenance performed on dry-type transformers. These records can be used to track the transformer's performance over time and identify any potential problems. By following these best practices for maintenance and testing, you can help ensure the reliable operation and long lifespan of your dry-type transformers. Remember, a well-maintained transformer is a safe and efficient transformer. Consider the ambient temperature around the transformer when interpreting PI values, as high temperatures can lower insulation resistance readings. Also, keep in mind that the type of insulation material used in the transformer can affect the PI value. Different insulation materials have different dielectric properties and aging characteristics. Consult the manufacturer's specifications for the expected PI values for your specific transformer model. If you suspect a problem with the transformer's insulation, consult with a qualified electrical engineer or transformer specialist. They can perform a thorough inspection and recommend appropriate corrective actions. Low PI values can also be caused by surface contamination on the transformer's windings. Dust, dirt, and other contaminants can reduce the insulation resistance and lower the PI value. Cleaning the windings with a suitable solvent can help improve the PI value. However, be sure to follow the manufacturer's instructions and use appropriate safety precautions when cleaning the windings. In some cases, it may be necessary to re-impregnate the transformer's windings to restore the insulation's dielectric strength. This process involves removing the old insulation material and replacing it with new material. Re-impregnation should only be performed by qualified personnel with specialized equipment. When troubleshooting low PI values, it's important to consider the transformer's operating environment. High humidity, corrosive atmospheres, and vibration can all contribute to insulation degradation. Taking steps to mitigate these factors can help extend the lifespan of the transformer. For example, installing a dehumidifier in the transformer room can help reduce humidity levels. Applying a protective coating to the transformer's windings can help protect them from corrosion. Isolating the transformer from vibration can help prevent mechanical damage to the insulation. Remember, a proactive approach to transformer maintenance is the best way to ensure reliable operation and prevent costly failures. Regular inspections, testing, and maintenance can help identify potential problems early on and allow you to take corrective actions before they lead to major issues. In summary, the Polarization Index is a valuable tool for assessing the condition of transformer insulation. By understanding the factors that can affect PI values and following best practices for testing and maintenance, you can help ensure the reliable operation of your dry-type transformers. Don't neglect the importance of proper documentation. Maintain detailed records of all transformer testing and maintenance activities, including PI values, test dates, and any corrective actions taken. This information can be invaluable for tracking the transformer's performance over time and identifying potential problems. The use of thermal imaging can also be beneficial in identifying hotspots in the transformer, which could indicate insulation problems or other issues. Consider incorporating thermal imaging into your regular maintenance routine. If you are unsure about any aspect of transformer testing or maintenance, always consult with a qualified electrical engineer or transformer specialist. They can provide expert guidance and ensure that all work is performed safely and correctly. Stay informed about the latest industry standards and best practices for transformer maintenance. Organizations like the Institute of Electrical and Electronics Engineers, also known as IEE, and the National Electrical Manufacturers Association, also known as NEMA, publish valuable resources on transformer maintenance and testing. Attending industry conferences and workshops can also help you stay up to date on the latest developments. Remember that transformer maintenance is an ongoing process, not a one-time event. By making regular inspections, testing, and maintenance a part of your routine, you can help ensure the reliable operation and long lifespan of your dry-type transformers. It is also important to consider the impact of harmonics on transformer performance. Harmonics are distortions in the voltage and current waveforms that can cause overheating and other problems. If your transformer is serving loads that generate harmonics, such as variable frequency drives or electronic equipment, it may be necessary to install harmonic filters to mitigate their effects. Proper ventilation is crucial for dry-type transformers. Ensure that the transformer is located in a well-ventilated area and that there are no obstructions to airflow. Clean the transformer's cooling fins regularly to remove dust and debris. Consider installing forced air cooling if the transformer is operating in a high-temperature environment or under heavy load. Surge arresters are essential for protecting transformers from voltage surges caused by lightning or switching operations. Ensure that surge arresters are properly installed and maintained. Test them regularly to verify their functionality. Grounding is critical for safety in proper transformer operation. Verify that the transformer is properly grounded and that the grounding system is intact. Check the grounding connections regularly for corrosion or damage. Overloading can significantly reduce transformer lifespan. Monitor the transformer's load and ensure that it is not exceeding its rated capacity. Consider upgrading to a larger transformer if the load is consistently near the maximum rating. Insulation breakdown is a major cause of transformer failure. Regularly inspect the transformer for signs of insulation damage such as cracks, discoloration, or oil leaks. Perform insulation resistance testing to assess the condition of the insulation. Partial discharge can damage transformer insulation over time. Conduct partial discharge testing to detect the presence of partial discharges. Implement measures to mitigate partial discharge activity. Moisture can significantly reduce transformer insulation resistance. Protect the transformer from moisture and humidity. Install a dehumidifier in the transformer room if necessary. Regular cleaning is essential for maintaining transformer performance. Clean the transformer regularly to remove dust, dirt, and other contaminants. Use a vacuum cleaner or a soft brush to clean the windings and cooling fins. Vibration can damage transformer windings and connections. Isolate the transformer from vibration sources. Use vibration damping pads or mounts. Temperature monitoring is important for detecting overheating. Install temperature sensors in the transformer windings or core. Monitor the temperature regularly and take corrective action if it exceeds the recommended limits. Oil leaks can indicate insulation problems or mechanical damage. Inspect the transformer regularly for oil leaks. Repair any leaks promptly. Winding deformation can occur due to short circuits or overloads. Perform frequency response analysis to detect winding deformation. Loose connections can cause overheating and voltage drops. Check the transformer connections regularly and tighten them if necessary. Bushing problems can lead to flashovers and transformer failure. Inspect the transformer bushings regularly for cracks, damage, or contamination. Online monitoring systems can provide valuable insights into transformer performance. Install an online monitoring system to track key parameters such as voltage, current, temperature, and oil level. Power factor correction can improve transformer efficiency and reduce energy losses. Install power factor correction capacitors to improve the power factor. Consider energy-efficient transformers to reduce energy consumption and operating costs. Energy-efficient transformers have lower losses and can save you money over the long term. Regular training for personnel is essential for safe and effective transformer maintenance. Provide regular training to personnel on transformer operation, maintenance, and safety procedures. Detailed documentation is crucial for tracking transformer performance and maintenance activities. Maintain detailed records of all transformer inspections, tests, and maintenance activities. Emergency preparedness is important for minimizing downtime in the event of a transformer failure. Develop an emergency preparedness plan that outlines the steps to take in the event of a transformer failure. Consider having a spare transformer on hand to minimize downtime. Collaboration with experts can provide valuable insights and support. Work with experienced transformer specialists or consultants to get expert advice and support. Compliance with standards is essential for ensuring safe and reliable transformer operation. Comply with all applicable industry standards and regulations. Continuous improvement is key to optimizing transformer performance and maintenance practices. Continuously review and improve your transformer maintenance program. By following these best practices, you can help ensure the reliable operation, long lifespan, and safe performance of your VPI dry-type transformers.